Let's have a look at compiling some code for the W806 MCU. First, you'll need to get the compiler tools, and to do that, we'll go on to the web page that I have highlighted here, which is github.com/wm-sdk-w806. I'll have these links inside the description also. Once you get there, you'll be at this web page, and as you see, it's got a bunch of stuff in the repository for the SDK. And what we want to do is we want to scroll down here to the install it section. For this, I'm going to be primarily talking about Linux, but there are sections for Windows, as we'll see down here below. We scroll down here, you'll see, and it's pretty much the same except you're using the MSys tools, and you'll have to have that installed on your machine as well, and also some extra packages for the GNU stuff. But for this, I'm going to assume you're going to be using Linux, and that's what I'll go on. I will add a side note here. If you're running Windows 10 or Windows 11, you could possibly get by using the Windows Linux subsystem and installing something like the Ubuntu image out of the Microsoft Store. And there possibly could be a Debian image as well. And with that, you may be able to run the Linux install just like you would normally here, because it is a Linux system. It's actually a very nice thing that Microsoft's done. I didn't say that though. But you may be able to do that. That's just a side note. I'm not sure, but something to look into. First thing we want to install now is the compiler tools. And this is the web link I used for that, this particular one right here. Once you click on that, it will carry you to this guy right here, to this page. And for Linux, you want to pull down this particular image right here and download it to your local machine. Once that's done, you want to unpack it. I unpack mine into my optional directory, inside my home directory. Really doesn't matter where you put it, just remember where you did put it, because you'll need to know that to tell the system where it is. And we'll do that in a couple of steps from now. Once that's done, and I'll show you here where I did mine. Mine is in my home directory, in my optional directory, and I have it under, I created a C-Sky directory, and I unpacked it there. So it's under my OPT/C-Sky, and then the contents of that is unpacked to that location. And then here you get your bin folder, which is where all the tools are. Some of the C-Sky stuff itself, I'm not really sure what's there. Include, lib64, execute, blah, blah, blah. So, but that's there. So just remember where you put it. And from there, what you want to do is go back to the I/O settings page, and we want to install the actual SDK. There's two ways to do this. The way I did it, I have the GitHub tools installed for command line use on my machine. A lot of Linux users probably have it as well, and Windows users. You can install that as well. And I just did a git clone. I performed this step right here. and that pulled it down, and I did it from my home directory, so it was in my home directory, and that created this directory right here, this WM-SDK-W806 directory. But if you do not have the tools, you can go to the page here, code, download zip, and then unzip the file and unzip it wherever you want to. And then from there, go to a command line and cd to that directory. And then we'll perform this next step. And to perform the next step, we'll go to a command line again. And I'm already in the directory, so I have it right here. So it's in my home directory, so I'm here already. So now what I want to do is do a make menu config and spell that right. And once that's done, it's going to go and it's going to create the menu tool, which is this guy right here. The only thing we're going to worry about right now is this particular option, the tool chain configuration. And remember, I told you about that directory where you actually put the tools, the compiler tools. That's where you want to change that here. And I have mine in my home directory, opt/csky/bin. So you want to tell where the bin directory is for that package that you unpacked. And also you want to put the last slash here because it does not do a check to see if it's there or not to add it. So you want to do that or it'll not find the tools. So change it to where your location is for the compiler tools, the bin location. And then once that's done, okay. And this should be the same. So you leave that and exit. And now go to download configuration. If your USB port is going to be different from what the default is, I'm not sure what it says for Windows, but my default was USB 0 and that's the one I'm using, so I left it the same. But if it's different, change it here. Leave the download rate the same and then exit and then do a save. So I'm not going to do a save because I'm done. So but do a save after you make your changes. Exit. And now what you want to do is you want to make, and this will go through, it'll make all the extra tools it needs, like the WM tool and then the firmware. And the first firmware it's actually going to make is the PWM example that it has in a demo. That is the default example that's in the directory that it compiles for the binary. This binary right here is what gets loaded to it, and your board will be blank when you get it, or it should be. Should be no code on it. So to do a test, you just do a make flash. Flash comes up, does it, and now when you see the wait serial sync, you hit your reset button on your MCU on your board. It comes up, starts it, and downloads it. Okay, the tool they have is also for the W800 board, which is Wi-Fi enabled, so your MAC address will not be filled in here, so it'll be, what you see here, the CCCC. But it'll say start download and then download 0 to 100%. It only does 4 blips. And then download complete and then reset command sent. There is a way to get it to reset the board automatically, but I haven't changed that. I just do the reset right now manually, so it's not a big deal. So I may look into that, or you can look into that. It talks about it in the documentation, and I think it's a define inside one of the header files they have, and you may be able to change that as a a make parameter in the make file somewhere. But anyway, so at this point, if you download it successfully, what you should have is this. You'll see the LEDs fading in and out for the 3 LEDs. And these 3 LEDs are connected to P0, P1, and P2, respectively, from top to bottom. Or PB, they're on the P bank side. Or excuse me, the B bank side. It has two banks, R and, excuse me, A and B. And where's where the GPIOs are for this guy. So after that, you're at this point, you should be okay. So now let's get some extra code on there, or some new code on there. And to do that, we're going to pull this down, and we're going to go to a new page. Next, you want to go to this, to this web page. And this is a GitHub that I've created. And inside this GitHub, I have several things, but one is a basic Blink type sketch or program, whatever you want to say it. But once you get there, we'll go to there now. This is the site. And in here, I have the main.c program, which is the actual code for the Blink. 2 support files, and the way they have it set up, they have these 2 support files for each of their demos, and so I followed suit with that, which you could take everything in these 2 files and place them in your main. They're just functions and a couple of defines, so that could all be in one file, but I left it as that. The way the make is set up is it compiles everything in that one directory together as one program to put in that binary file that gets downloaded. So what you want to do is you want to either clone this repository or download it this way, which is just fine. So it doesn't really matter here at all. And once you do that, you want to unpack it to some place that you know. I have mine unpacked in my home directory. And once you're there, let's get back to the coding. Copy these in real quick. On a command line. Okay, so we want to do a copy. We just want to, for this, we just need to copy the C files. The make file is actually already in the directory, so you don't have to copy it if you don't want to. So we'll copy from my home directory, and it is under W806 Blinky, Blinky. I want to copy star.c, and we want to copy that to this directory right here, and it will be your WMSTK app. So wherever your WMSTK directory is, then the app, then the source directory. That is where the files it compiles to put in the binary gets downloaded. So this is where we're going to put our Blink code. And we do that. And we run the right copy command. Switch between, I do a lot of retro DOS stuff. There we go. So now We come up here, and I had these loaded in already, so it's going to automatically change right here. And here's the blink code. This is the code I wrote, and I have instructions in here on how to do this as well. And this is kind of your most basic code for the HAL system. Well, I guess it could be a little more basic, but for our purposes, the most basic. And what I do is I flash 3 LEDs, as you'll see. In turn, I start with the middle one, which is GPIO pin 1, and then I go to the bottom, which is 2, and then the top 3. So I do them all in turn, on and off, on and off, on and off. And this is our main, and you can think of this as your kind of as your setup, but in this particular case, it's not your setup, but it's your main program. And in the wiring and Arduino world, you have your setup, and main is hidden. Main is there, but it's hidden from you. So here's our main. From there, we're going to perform our setup, and we go down and look at the setup, and it creates a structure for the GPIO init, initializes it to nothing, and we set the system clock to 240 megahertz. This has to be done as well too, and it can be 160, 240, and there's probably a few others, but I took the full tilt, so we're at 240. And notice this comment here: for any HAL function to be called, and HAL stands for hardware abstraction layer, and that's a common, it's kind of like the wiring layer you have for Arduino inside the Arduino system. But this is HAL. HAL came from the STC system, that like the STC32s. But other ARM chips follow suit with that as well. And it may have not been the first one. There could have been other ones before the STC being using it, but I'm not sure. At any rate, the HAL system is pretty standard, and it's a fairly thin layer over the hardware. It's not as thick as the hardware layer is for the Arduino, so the performance is pretty good on it. We do the init, and that sets it up so the HAL system can be used. And then after that, this guy right here is called HAL RCC GPIO clock enable, and that enables the GPIO system. And then from there, after that, we can define our pins that we want to use. In this particular case, we're going to be using pin 0, pin 1, and pin 2. And these are all on bank B. And we set them up for output, which you're pretty familiar with that. And then we're using no pull up, and then we call the function to actually initialize those pins. So that sets the mode and everything all at once. Now you'll notice here that we're doing multiple pins at once, which is a nice thing. We're just ORing them together. These are numbers that are getting ORed together. So if we could do this as well too, but since we're doing 3 at a 3, and they're all together on the same bank, and it has to be on the same bank also. We're just gonna do that. So we do that, and then so we're ready. But there is more here. We have 2 other files. We have the wmit.c and the wm_hal_msp.c. We'll look at this guy first. And what this one does is it sets up your clock system. For your clocking, for your running and stuff. Kind of think the stuff that runs mills under the Arduino. This is what this is. This brings in the clock counter for into scope, and this is a peripheral. Our address for peripheral. If you want more information about the different peripherals for the ARM Cortex M0s, just go to here. They all follow suit with this. And this increments the tick counter. And this is an interrupt, by the way. And you've seen this with Arduinos, I'm sure, before. So it's set up as an Arduino, excuse me, a service handler, interrupt service handler. And so once, however many times this is run, this gets incremented. So it keeps your counter going for your timer. This we'll want, so this will always at least have this in it. When you look at the other examples, you'll see more things in this file as well. But for this example, this is all this is. Now for the HAL MSP, we are not doing anything for this. And this is the MSP this is for the microcontroller unit support packages, and we're not using any other packages here, so we don't need to initialize anything here. So I'll leave it blank, and we'll go back to this guy, our main, and this is the meat and the bread and potatoes of our program, or our code. And all we're doing is, while true, and this is equivalent to your loop in the Arduino world, we're going to toggle the pin 1, delay 1 second, toggle it again, delay 1 second, move to the second LED pin, toggle, delay, and then the third toggle, delay, and so forth, and keep going until Hades or other places that you may or may not believe in freezes over. So, and that's pretty much it. That's the simplest I could make it with it doing something. So, and with this board having the 3 LEDs, I decided to go ahead and just flash all 3 of them in some special way. So now let's go and install this code on there. Okay, I copied the code over, but I need to do a make clean again to make sure the code gets compiled. If not, it would not, or I could go touch the binary or something, so that cleans it up. And once you're developing and doing your changes and changes to the code, you don't have to do the make clean each time unless you want to, because that'll make all the tools again in libraries, but not a big deal. It doesn't take that long to compile. And then once we're done there, we want to do a make, and it goes through and it's making all the tools and stuff again, like I said this time. But hey, let's go do this. Let's go change this guy. We'll save it and get back here. Clear. We'll do a make again. Oh, what did I do? Hey, I introduced air. Okay, let's see where the air is. Before return. Oh, did I delete? Oh, I deleted. No. Okay, let's do this. I deleted the while. Okay, so now we'll save it again and do a make. Okay, so the only thing it should have made, and we'll go up here, is our main, because we changed our main. So, and it created a new app user for the bin. So now what we're going to do is we're going to say make flash, and once we get our wait serial sync again, we hit the reset and it flashes, and here we go. There's our blank code. Get it out there so you can see good. So it's flashing the LEDs instead of doing the fades like it was doing. It's running our new code. So that's it. It's not really complicated. They don't have a make system set up for it so far that's, you know, decent, which is not good, but that's just the way it is for right now. If you want to compile any of the other examples, and if we go look here, and we're in the SDK directory already, so go to demos, and we have these demos right here. ADC, Flash, free real-time operating system, GPIO, I2C, I2S, PMU, PWM, and PWM is what the default one was that we saw it fading the LEDs in and out. RTC, real-time clock, SPI, and this does have a LCD controller built into it, and supposedly it handles several LCDs, and this one's a touch. So TFT, LCD, TIM, I'm not sure what that is, and touch for like touch pins, you know, that most processors have now. UART and a watchdog timer. So you should be able to take any of these and copy them into that same directory. Like we could do this. We could go copy, copy ADC. I'm not going to do it, but copy ADC. Demo. To our AP source directory, and it would replace those, and you would be able to compile those just like we did the Blink application or the Blink sketch. But so you should be able to do that, and you're free to do that. So but hopefully at some point they will get a better system so you can make things on your own a little easier, which isn't too hard, but this is the easiest without having to take their make files apart and configurations, and I'm lazy in that particular way. And I hope at some point they'll get a platform IO set up for the compiler tools for this, like they do for the things like the SDC and other ESP things like that. And they may even do an Arduino wrapper for it. There's a good bit of code they'll have to do for the wrapping of the how functions into the wire, to make them look like the wiring stuff. But anyway, I hope this helps someone and to get some code out of their or code into their new microcontroller if they have this guy. And I hope you have a nice day.